two candles, A and B, are of the same length. Candle A takes 4 hours to burn completely. Candle B takes 3 hours to burn completely. If both candles are lit at the same time and allowed to burn uninterruptedly, after how long would candle A be 2¼ times as long as candle B? We're talking about the heights of the two candles. I'm going to solve this problem visually, and it's also called direct modeling. I'm going to see what happens to the two candles every half an hour, and I'm going to hope I get my answer in one of those time frames. So half an hour, 1 hour, 1½ hour, 2 hours, 2½ hours, 3 hours, so on and so forth. So I'm going to do the problem, solve the problem visually. If you want to try the problem on your own, please pause the video and try it. So what I did, I started with two candles and made sure the candles are 24 units high. And where's 24 coming from? 24 is 4 times 3 times 2. 4 is the number of hours it takes for the first candle to burn completely. 3 is the number of hours it takes for the second candle to burn completely. And 2, I just made it twice. I could have used 12, but since I said I'm going to look at what happens every half an hour, the half, 1/2, if I multiply it by 2, I will be avoiding fractions. And if you count carefully, you will see there are 24. Candle A is 24 units tall, and candle B is also 24 units tall. And what happens after 1 hour? After 1 hour, from candle A, this is gone, because candle A takes 4 hours to burn completely. This is 1/4. After 2 hours, this is gone. After 3 hours, this is gone. After 4 hours, the entire candle A is gone. What happens with candle B? After candle B, recall, takes 3 hours to burn completely. So after 1 hour, 1/3 is gone. After 2 hours, 2/3 are gone. After 3 hours, the whole candle, 3/3 are gone. So this is the background of our problem. Now we're going to directly model this problem and see if we can solve the question. So this is the original scenario. We just light both candles and wait for half an hour. This is what's going to happen. Now we claimed that in 1 hour this is gone. So in half an hour only half of that will be gone. And candle B loses this much in 1 hour. So in half an hour this will be gone. So this is half an hour. What happens after 1 hour? After 1 hour, candle A loses this much. Candle B loses this much. Now clearly, candle A is not 2¼ times. 2¼ times would mean candle A is twice as long as B and 1/4 times as long. So let's go on and see what happens after 1½ hours. After 1½ hours, another half of the next hour is gone from candle A, and from candle B, another half of the next hour is gone from candle B. Now clearly, candle A is not twice as long as candle B, so 1½ hours could not be the right answer. So let's try 2 hours now. Okay, after 2 hours, candle A loses 1/4 plus 1/4, which is half. And every hour candle B loses 1/3. So after 2 hours, candle B loses 2/3. But is candle A 2½ times as high or tall as candle B? The answer is no, because you can actually start paying a little more attention to the height now, because they're getting there, right? So this is the height of candle B. This is the height of candle A. And if you divide, if you count these units, 1, 2, 3, 4, 5, 6, there are 12 units for candle A, 12. And there are how many units? Candle B is how many units high? 1, 2, 3, 4, 5, 6, 7, 8, 8. Now, if you divide 12 by 8, you get 1.5, not 2¼ Okay, that's fine. Let's go ahead and analyze the scenario after 2½ hours. After 2½ hours, this is what you're left with. Okay, another half hour gone, another half hour gone. And how many units high is candle A now? Candle A is 1, 2, 3, 4, 5, 6, 9 units high. I'm going to write 9. And candle B is only 4 units high. I'm going to write 4. Now, is candle A 2 1/4 times as tall as candle B? The answer is probably, quite likely. Try it out. 9 divided by 4 is 2 1/4. So the answer is, after 2.5 hours, candle A is 2 1/4 times as long as candle B. So the answer is, I'm going to write the answer in green. The answer is 2.5 hours.